All right, welcome everybody to our webinar on heat pump water heaters, new developments for retrofits and multifamily buildings. My name is Geoff Wickes. I'm here with Electrify Now, here with my teammate, Brian Stewart. We'll introduce our panelists, Geoff and Amruta, in just 1 second. And we want to welcome you to day 2 of Sustainable Building Week and what we're calling Electrify Week within Sustainable Building Week. Huge thank you to Sustainable Building Week for hosting our 5 webinars, 1 webinar every day on a topic around electrification. Huge thank you to the sponsor of Sustainable Building Week. You can see New Buildings Institute is a sponsor, and Amruta will be representing them today. And just really great to be with you, and we'll put a link in the chat to Sustainable Building Week. So Electrify Now, for those of you joining us for your first Electrify Now webinar, we have a lot of choices facing us when we try to be more sustainable and decarbonize our life. We're trying to boil them down into some of the most impactful choices that you can make to decarbonize your life. And they involve electrification. So number 1, clean up your electric supply, get solar energy on your rooftop, community solar, sign up for your utilities clean energy plan. Number 2, electrify your home. We're gonna be talking about one big system in home electrification today called heat pump water heaters. 3 is electrify your ride. We have a great YouTube video, Google Electrify Now YouTube to watch our EV webinar. And then number 4 is electrify everyone. So Electrify Everyone, you may have seen as you signed up for this webinar, is this program that we have launched in partnership with a local nonprofit called Community Energy Project. Together, we are fundraising to replace old, inefficient, polluting gas hot water heaters with new and efficient heat pump water heaters in income qualified households. We're over 50 water heaters. We've raised close to $4,000 just through our webinars alone. Thank you so much for donating. We'll put a link in the chat. Thank you to you all. So this is Electrify Week, and we're going to try something for the first time ever in Electrify Now history. We are going to launch a poll. We're curious to see where our audience is coming from for Electrify Week. So if you feel comfortable, go ahead and vote and tell us where you're hailing from and what industry you represent. And while you're doing that, we did a little bit of number crunching today, and for Electrify Week, we've had over 1,300 people registered just for this week. We're so excited about that. 700 of them are unique viewers, and they're representing 28 countries. Can you believe that? Among those countries are Uganda, Singapore, South Africa, Malta, Haiti, Algeria, and Argentina. So welcome to you all. If you feel comfortable in putting where you are hailing from today, go ahead and do so in the chat. We'd love to see where people are coming from. You know, this electrification movement is a worldwide movement, and we're so excited to be part of it with you all. We'll give you another minute to finish up that poll, and then we'll share the results. And of course, so Electrify Week, we've done one event so far, all electric versus gas. That's up on our YouTube channel. Today, we're talking about heat pump water heaters. And then every day we're doing a webinar at noon. Tomorrow, we're gonna be talking about grid interactive buildings. Thursday, induction cooking, and then Friday, healthy homes, where electrification and equity intersect. So join us for all those. We'll put links in the chat. Okay, so I'm going to end the poll, and I'm going to share the results. Great.
Oh, that's really interesting.
Yeah, so most folks are interested homeowners. That's fantastic. But architects, designers as part of Sustainable Building Week as well. Great. Well, so Brian, what are we going to be talking about today?
Oh, first of all, let's we should do a quick shout out to our Electrified Coalition. We've got over 40 organizations now. They're all part of Electrified Coalition, all like-minded groups who are interested in promoting electrification. If you're one of those groups fits that description, you'd like to join us, we'd be happy to talk to you about joining our coalition to help push this amazing solution. All right, as you said, Joe, why are we talking about focusing on water heaters? Why are we talking about this? Well, I like to kind of start by just reminding people, or maybe introducing the idea that your house is not unlike an automobile in terms of its impact on our carbon emissions. And so it's just that we don't see it in the same way we see it with cars. So for example, with your car, every time you go to a gas station, you're going to put the nozzle in there, and you're very aware of the fuel that's flowing through there. You can smell it, you can hear it, you can feel it, and you know where it came from. It came from this oil field far away. And when you turn your car on, it burns that fuel. And you're also very aware of the pollution that comes out the tailpipe. You can smell that, particularly when your car starts out, or maybe you're at an intersection, you're seeing cars go by and smelling that. There's also carbon emissions associated with that most people aren't as aware of. It's typically about 4 to 8 tons for an automobile. If you have a small car, you don't drive it a lot, it'll be lower. If you have a big car and you do a lot of long distance driving, it could be 8 or even more tons per year. Average is about a little less than 6 for an automobile in the United States. So that's the situation for a car. It's not that different for your home. If you have a gas heated home, you've got this pipeline that goes into your home. So you're not pushing the nozzle into your house to fill it up. So you're not as aware of the fact that this gas is flowing into your home. But it came from a lot of those same places: oil fields, fracked gas fields, etc., refineries along the way, through your gas meter into your house. We burned that fuel in our homes that creates pollution, some of which, by the way, stays inside your home. There's more and more evidence of that all the time, particularly if you don't have good ventilation and you have a electric or a gas cooktop. You might be breathing some of that pollution, carbon monoxide, carbon nitrous oxides, etc., in your home, but most of it goes up your flues into the outside world, up high. You don't really notice it. So, but the carbon emission impact is very similar. I mean, it can be in the range of 4 to 8 tons, again, depending on how big your home is, how much hot water you use, how much heating you use, etc., how many gas burning devices you have in your home. But it's very similar. It's just that we don't see it. It's not as obvious. But I think that's a good way of just like introducing the topic of our homes being a problem to solve, just like cars are a problem to solve, in terms of how do we get the heat that we need, the hot water we need, without this carbon emission problem and pollution problem. The big culprits in our homes, so to speak, the two big daddies in terms of creating carbon emissions, are your furnace, which again is going to create somewhere between 3 to 5 tons, depending again on how much you use. It can be wildly variable. If you're in an apartment, it might be even less than this, but something like 3 to 5 tons. And then it can be 1 to even as high as 3 if you use a lot of hot water in your home for your gas water heater. A lot of people are surprised your gas water heater is your number 2 energy absorbing device. And Amruta and Geoff are going to talk about this in more detail as we go into this. But if you're having trouble getting your brain around what a ton of carbon looks like, because it's pretty hard to imagine, I like to use this analogy. Every time you take a hot bath, let's just say, and this is relatively similar if you're taking a hot shower, the energy it took and the carbon emissions it takes to heat that water with your gas water heater is essentially the same amount of carbon dioxide that would be released from making the plastics that it would take to fill your tub with plastics waste. So think about plastic bags and cups and all that kind of stuff that we really hate. The carbon emissions it takes to make a pile that would fit in your bathtub is pretty close to the carbon emissions that it took to heat that water in the first place. So that's a visual that helps you see or feel the impact from this invisible carbon emissions thing. I hope that helps you. All right. So today we're going to be talking about heat pump water heaters, and we're going to be talking about what's out there and what's coming. What are the new developments that are emerging? Because this is a fast changing technological area, and we've got 2 experts to help us to see the exciting stuff that's going on in this area. There's a whole new classification of heat pump water heaters, this 120 volt solution that's coming that we're going to hear about, and why that's an important development. And then what about central heat pump water heaters? You know, a lot of us live in multifamily houses or apartment buildings where there's a central boiler. How do we deal with that problem, and how can heat pumps help there? And then what does it cost to do this? And what about, operating them in terms of energy costs? This is the stuff that we're going to dive into today. And I want to introduce our 2 amazing panelists. We've got 2 experts on this. We couldn't ask for anyone who knows more about this than these 2 people. Amruta Khanolkar from New Buildings Institute. She has experience in and expertise in energy efficiency, decarbonization, and demand response, all which working to help improve the performance of the built environment and lower impacts of our buildings. Her work includes energy efficiency programs, best practice guidance, and emerging technologies, which is what she's going to be talking about today. She has a master's in science degree in energy efficiency and climate responsive built environments from Arizona State University. So welcome to Amruta, and she'll be leading us off. And then she's going to be talking about the new developments particularly in the 120 volt area think about it as like replacements for residential water heaters in that area. She'll be talking about that. And then we have Geoff Wickes to talk to us about what's going on in the multifamily zone. He's the senior project manager working with the Advanced Water Heating Initiative, which he'll talk a little bit about, but it's a fantastic organization that's really helping to push and drive new developments in hot water heating solutions to lower the energy use and the emissions from those devices. He works with utilities and trade allies to prove out these new innovative energy efficient technologies and help transform the water heating market, as well as other emerging markets. He has a background in energy efficiency and conservation, and he's been working in the fields of instrumentation, manufacturing, construction, and IT. And he's an Oregonian here with a BS in geography and liberal arts from Oregon State University. I hope you Duck fans won't count that against him. So welcome to both Amruta and Geoff. And with that, I'm going to turn it over to Amruta to take us into the first part of this conversation.
All right. Thank you, Brian, for the warm welcome and the introduction. Hello, all. This is Amruta Khanolkar, New Buildings Institute, and I'm going to share my screen. Can you see my screen? Can Joe? Okay. All right. So today I will be giving you an overview of residential style heat pump water heaters, and the later portion of my presentation will be focusing on the emerging technology, the Retrofit Ready 120 volt heat pump water heaters. So as I mentioned, I will be starting with giving some context, like with some context setting on heat pump water heating, the water heating in general and the national landscape. Then diving deeper into the Retrofit Ready 120 volt emerging technology, the technology status, where the technology is currently, and then the technical proof of concept field study that we have under development in California. So I'll give you some overview on that, where we are and what's the plans are, and finally about the Advanced Water Heating Initiative, the overarching market transformation effort. So as Brian just mentioned, space and water heating account for 2/3 of home energy in a typical household in the United States. And so just looking at those two end uses from decarbonization perspective, they are the most end uses that we need to tackle to address the climate crisis. So what you see on this slide is the water heating stock in the United States nationally. So the overall nationally, it's the second last row is the water heating stock in California, and more than 90% of California's water heaters and 50% nationally water heaters are directly pumping fossil fuel for heating their water. So they are either gas, propane, oil-based water heaters. And I see that there are very many Northwest attendees. So in the Northwest, it's similar to national average, which is like 50-50. About 50% of the water heaters are directly pumping fossil fuel for heating water. So to give you some context to those numbers, there are about 118 million water heaters nationally, just residential water heaters, and about close to 4.6 million commercial scale water heaters. About 40 million water heaters are 10 years and older. So they are ready for replacement, like, close to end of life. And more than 7 million water heaters get replaced every year. So just looking at the opportunity this technology, heat pump water heaters have in front of us, from like saving energy, also like emissions. They can the efficient heat pump water heaters are about 2 to 4 times more efficient than any conventional water heater, like take it a electric resistance water heater or a gas storage, a condensing water heater. So just this technology alone has tremendous potential to reduce greenhouse gas emissions. So what are heat pump water heaters? And I know like most of you know about this technology, so I don't plan to spend too much time on this slide, but to those of you who don't, um, the heat pump water heaters do not generate heat, they transfer heat from one location to another. And that's why they are efficient than a conventional water heater. And as I mentioned, they're about 2 to 4 times and more energy efficient compared to a gas or electric resistance water heater. And 3 to 5 times they save like carbon emissions 3 to 5 times compared to a conventional water heater. So on this slide, I just wanted to, I'm going to move okay, I just wanted to show the current manufacturers and the technology status, the criteria, the unique features that these heat pump water heaters have. So there are about 6 residential style manufacturers in the United States that are out with the products. And again, these products, like the typical 240 volt heat pump water heaters, are there in the market for decades, like more than 40 years. So not that this is a new technology, the 240 volt heat pump water heaters are there, tested, tried, and ready, prime time for decades now. And maybe I should clarify that by residential unitary heat pump water heaters, I mean in-unit water heaters that can be installed in single family or even in multifamily, in closet, like indoor closet or outdoor closet, but these are in-unit water heaters. And my co-presenter, Geoff Wickes, he will be capturing the central side of the central heat pump water heaters. But bringing focus back to the residential, there are like about 6 manufacturers. The 240 volt technology exists for years. The 120 volt, the Retrofit Ready 120 volt water heaters, there are about 4 manufacturers with market ready products. And my next few slides will focus on that. So that's the second last column is about grid connectivity and CTA 2045 port. So that's where the grid connectivity aspects and optimizing these electric water heaters to electric rate structure is very key. And almost all of these manufacturers have a CTA 2045 port, which is a standard universal connectivity port available. So that's a key feature. I'm moving on to the refrigerants. Right now, only like 2 manufacturers are looking at low to medium global warming potential refrigerants. But with where California and the CARB, the California Air Resource Board regulations are going, or with where overall with where we all are heading, all of these manufacturers are researching the low global warming potential refrigerants in the heat pump water heaters. Moving on to the next slide. So one of the key technical barriers of heat pump water heaters is having a 240 volt electrical connection available next to the water heater, next to their existing gas water heater. And that brings me to the emerging technology. So from these slides onwards, I will focus on the Retrofit Ready 120 volt water heaters that are market ready and coming to market. So the first few slides where I showed that about 90% of Californians and what 50% in nationally water heaters are using gas, propane, or oil to heat their water. And for those customers, or for those people, if they want to decarbonize and switch from a gas water heater to an electric water heater, the only option they have currently is going for an expensive panel upgrade. But if this new emerging technology, which is the 120 volt water heaters, if this technology, once it is validated, the customers will no longer have to do that. These emerging 120 volt heat pump water heaters can be plugged into an existing electrical outlet without requiring a panel upgrade. So just a little bit about the status of this technology. About 2 years ago, like in 2018, end of 2018, in a Retrofit Ready summit, the stakeholders came together, identified a gap that there is a need for this technology to be developed, and they developed specifications for the Retrofit Ready heat pump water heaters. And those tech specifications are now part of NEA's Advanced Water Heating Specification version 7.0, and also Energy Star specification version 4.0. There are about 4 manufacturers with 7 products, 7 unique products coming to market, already in market or coming to market between 2021 and 2022. These products are mostly on shared circuit. There is one product on dedicated circuit plug-in heat pump water heaters. The way the manufacturers are trying to like achieve the same similar performance with these 120 volt is, so the main difference is they do not have any electric resistance element in them the way 240 volt is. The existing heat pump water heaters have electric resistance. This new emerging technology does not have electric resistance in them. And their new design is they're going for higher storage water temperatures. So instead of 120, they're heating their water to 140, 150, and storing them in a storage tank with an integrated electric mixing valve. So that allows, the mixing valve allows the water heater to gain the efficiency or to heat water the way the customers are looking for. So these emerging technologies are going to be in different tank sizes, 40, 50, 65, and 80 gallons. They are going to be CTA 2045 compatible. And by that, I mean they will have a universal connectivity port that can be a time of use rates, that can allow time of use scheduling, or also utility demand response ready. So those are some of the key features of this new technology. And by new, I mean like technology that exists, but they have a unique design with this integrated mixing valve. We did some comparison of different fuel types, just looking at the heating capacity, like the input versus output. And what you see here is the first column is natural gas, the second column is electric resistance, and the last 3 columns are the 240 volt, this existing heat pump water heaters, the technology that is in market for years. And the last 2 columns are the emerging heat pump water heaters with integrated mixing valve. So as you can see that the heating capacity, the input is almost 1/3 of a existing 240 volt heat pump water heater, and that does have some impact on the first hour rating, but a minimum impact on the first hour rating because of the integrated mixing valve. I'm going to give a couple of minutes for people to like just see how the first hour rating.
Maybe while we're on this slide, this is good just to pause for a minute, just to make sure people understand what we're talking about here. This first hour rating is that has to do with basically how much hot water you're going to be able to get in the first hour of use, which it roughly transitions in terms of, or translates to, you know, hey, how much hot water do I have? Do I have enough when I need it? Or does it going to have to, do I have to wait and let the water heater warm up again before I take a shower or whatever? So I think that bottom line, what it's showing is that the in the 120 volt situation, the mixing valve is pretty critical, because otherwise you might have a, maybe it's not as convenient to use problem, correct?
Yes. Yeah. Thank you, Brian. Yeah, that is exactly what it shows, that with mixing valve, they can be pretty comparable to the 240 volt heat pump water heaters, and even electric resistance heat pump water heaters.
Right. The other thing I think that jumps out to me, that one, or if you'd comment on, so if you look at the tank heating time, you know, there's a big difference between natural gas, for example, and the heat pump water heaters. But, you know, it's pretty rare that you're going from cold water to hot water. You know, I mean, that happens sometimes, like maybe you've had your hot water heater off for a long time, you've been out traveling or something, and then you come home and you turn it on, you go, oh my gosh, it takes a while. And it's true, the heat pumps are going to take longer to heat up.
Mm-hmm.
But from a use standpoint, that shouldn't be a problem, because your hot, once it's hot, it should be staying hot. Is that correct?
Yeah, that is a very good point, Brian. Again, this is based on the modeling conditions that the manufacturers use for DOE testing. But in reality, the heat pump water heaters, they do have a storage tank, and especially with the 120 volt heat pump water heaters, which is going to now store it at a higher temperature, 140 degree Fahrenheit. This is what you see here is just for the first hour, when it is going from 58 to 120. But in reality, because of the storage tank, it's not going to be, it's going to be pretty quick response. Okay, I know we have time after the presentation to go for more questions, so I will move on to the next slide. So from this slide onwards, I will go into give you an overview of the field study effort that we have going on the West Coast. So to independently field verify the energy performance, the installer acceptance, and also the customer experience, we are currently we are currently working on a field study on the West Coast. The field study is funded by Southern California Edison, PG&E, and also we have confirmation by SMUD, so 3 California utilities. We have 3 key research methods that we are using under this field study: metering and analysis to understand the hot water runout events, the energy performance and load shifting performance of these water heaters. The billing and cost analysis to understand the first cost to installation cost, and also do the operating cost analysis to see whether the bill savings go down going from a baseline to this new heat pump water heater, and surveying customers, installers, and manufacturers, mainly to understand the experience, the installer and customer experience. We are very careful selecting our sites to make sure that we are capturing all the key site criteria, and we are making sure that the sites are divided within the different California climate zones, from colder to hotter climates. We have about so we have 32 sites divided within 3 California utilities and all the climate zones in California, trying to capture single family as well as multifamily applications, looking at different hot water demand curves, for example, number of people, occupants, and type of occupants, install location, conditioned as well as unconditioned, like garage application, indoor, outdoor closets in multifamily, vintages of homes, and also income level of participants, and how does these different criteria impact our overall findings. The like the overall goal of this field study is helping this key emerging technology with supporting with commercialization and building demand. That is what we have been hearing from the manufacturers. So we want to make sure that with expediting this field study with multiple utilities and organizations, we can the results can help with developing a regulatory measure approval document or a work paper, like different regions call it a different name, but that will help with expediting the process for IOUs. And coming up with like raising awareness and coming with training materials that will help with overall market adoption and market transformation of this technology. I know I didn't get a chance to talk a lot about grid connectivity and controls, but I do want to mention in this slide that if used if heat pump water heaters are grid connected used with optimized controls, then this technology can in fact save us in operating cost. So advanced grid connectivity and optimized operation is key to save on operating cost, and this technology in fact can be comparable to tankless water heaters. This analysis is done with California time of use D prime rates in Pacific. I know we have many Pacific Northwest attendees. So I do want to mention that Pacific Northwest, the rates are lower. So you will see that the operating cost will be in fact lower than 110, will be maybe close to 90 or $100. With that, this is my last slide, actually second last slide. Key takeaways from the presentation is the existing 240 volt heat pump water heaters in the market for decades, and they're ready for prime time. The 120 volt retrofit ready heat pump water heaters, the emerging ones, if validated, can be a game-changing technology in the fight against climate crisis, and not maybe just limited to gas replacements, but also for key niche markets like manufactured homes. So it can be a game-changing technology. And finally, we need to test this emerging technology in other parts of the country to receive quicker feedback on climate variation, and also other applications like basement that we are not going to capture in California, but we need to see a faster market adoption of this technology. You can find more information about the field study in the link that is provided in this slide. And finally, I want to acknowledge that this effort is part of a bigger effort, that is the Advanced Water Heating Initiative. It's a market transformation effort of more than 50 organizations coming together to accelerate market adoption of heat pump water heaters. The vision is heat pump water heaters are the preferred choice in all water heating applications for residential as well as for commercial applications. With that, this is my email address. If you have more questions or would like to test this technology in other parts of the country, please get in touch with me. And I will.
Great. Thanks, Amruta. Geoff, if you want to join, we'll do a quick Q&A after this, and then you can go into your presentation. But if you want to come on camera, and please feel free to join the dialogue. That's fantastic. I mean, there's a lot of questions coming into the Q&A. I encourage people to put their questions there as they're coming in. So much comes into play with this, the heat pump, the retrofitted heat pump water heaters. I wanted to kind of just share that I have a heat pump water heater, and we run it exclusively on heat pump mode. And instead of kind of the mixing valve, I just raise the temperature a little bit in the winter up above 120. I'll go to 130. We have anti-scalding devices on all our faucets, so that seems to help. Amruta and Geoff, do you have any thoughts on that hack for folks? I mean, is that extra storage tank with the mixing valve really key in doing these retrofitted water heaters?
Yeah,
Geoff, you-
so I do have something to say about that, and I would say to Amruta's point with storage, for every 10 degrees of raising the water temperature from the factory setting, DOE federal standards require shipments to go out at 120. It's up to the homeowner or the relationship between the homeowner and the plumber if they adjust that temperature upwards. They assume the liability and responsibility of that. But for every 10 degrees lift, you raise that up in your water heater in volume. It in a sense creates an additional 10 gallons of volume of usable water. It's a weird sort of way to think about it, but you make a 50-gallon water heater, raise it to 130 degrees, it now looks and acts like a 60-gallon tank. Or if you have a 65-gallon tank and you raise it up another 10 degrees, it looks and feels like an 80-gallon tank. So that's one of the hacks. I would say, Joe, it's a great idea of raising the temperature. We typically run ours at about 123 degrees and runs year round that way. I don't mess with it on an annual basis, but you could if you've got higher loads in the winter or you've got teenagers in the house or something like that.
Yeah. And to add to Geoff, I would also like to mention that like heat pump water heaters can act like thermal batteries. So, they can heat water and at a higher temperature when you have like sun outside or you have wind blowing, you have renewables basically, and you can use that water again when the grid is dirty. So just to, use that feature of the heat pump water heaters, like using this higher temperature is a key and storing it is a key.
Yeah, we're going to get into that in a lot of depth tomorrow with this grid interactive buildings, but it's a really good point. I mean, that's why that communication module that Amruta was talking about that's really exciting news that's going to be a standard feature with these devices, because that's going to make connecting to the grid possible. Hopefully we won't even have to think about it. It just happens. But that amount of shifting loads back and forth, as we'll discuss tomorrow, is like a really critical part of us achieving a kind of really clean energy future that we're looking at. And it's attractive from the homeowner standpoint too, because it can save you potentially money, particularly in places that have these time of use rates. Here in Oregon, we don't have that so much. So although I think that's starting potentially changing, but in a place like California, it makes a really big difference whether you're heating your water, like Amruta was showing, whether you're heating your water at night or during peak times. It can make hundreds of dollars of differences in your total bill payment. So it's really important. I know that there was some people maybe feel like we glossed over just how heat pumps work, and I just want to, the easiest way to think about it, I think, is like a refrigerator. You know how your refrigerator works. It basically cools the inside of the refrigerator and basically your kitchen gets slightly warmer. So this is just the opposite, where you're basically inside the water heater, it's going to get really hot, but that means that the space around it gets cooler, which is why typically you put these things in uninsulated spaces or unoccupied spaces, or you duct them to the outside, so that your device isn't fighting your furnace. But it's an extremely efficient technology, insane. It's the same technology that we use for heat pumps for cooling and heating your homes. So, and as Amruta said, it's technology that's been around for decades and decades. It's just that it's getting better, and we're getting these new developments of applying it. I had a question for Amruta for you that came up. What about the noise of the 120 volt versions versus the 240 volts? Are we going to see any difference there?
Yeah, I will. I know Geoff will have more to address there, but I will absolutely mention that so they have the 120 volt heat pump water heaters have the same compressor as the 240 volt. So the same heart, same soul. The only thing that they don't have the electric resistance element in them. So I don't think that you will notice anything different in the 120 volt. Geoff, what do you think?
Well, so NIA is doing an extensive work on noise abatement within these. I saw that little bit of chatter in the chat box. These have come down in noise substantially. Best in class right now is 49 dBA. We're working with several acoustical engineers to send more information to the manufacturers. We think these will get down to closer to 45 dBA or even lower over time. The 120 volt will not be any more noisy than the current 240 volt. And if you ever get the option, always put in a 240 volt. Don't go for a plug-in. If you think it's a DIY hack, it's far better to have the extra horsepower of a 240. And these are pretty quiet. And I can show you a slide that shows the evolution of noise abatement over the last 10 years with this technology. They're making big inroads, fan blade design, compressor design, sound isolation, and even vibration pads. So I would encourage you to read up on the best in class, and we're promulgating that into the trades and into the manufacturer's installation manuals. Even isolation pads on your earthquake straps will help substantially. And certain frequencies is what bothers people. Noise is not seems to be a problem. It's the frequency of it. And so we're working to dig into that to figure out, how can we make that a better experience.
That would be a great one pager that we would love to have, is just like tools to help people if they are experiencing that. I mean, we haven't experienced that in our house, and Joe, I know
Yeah,
you.
I would say we have it. We have ours right in our utility closet. And again, anecdotal evidence. I feel like it's quieter than our fridge. So I was worried about it ahead of time, and then I was like, wow, that was a non-issue. So
yeah, I feel like our
so
fridge.
we're actually soliciting people who have noise complaints. We want to have a recording of that. We'll send it off to the acoustics lab, do the spectrum analysis on it, and we'll get you a result. And then there are kits made by some of the manufacturers who had a noise challenge during certain production models.
Yeah. We should probably, should we move on, Geoff, or Joe, maybe Geoff, we tee up your slides, and we'll have some more time for Q&A at the back end too, hopefully.
yeah, that sounds right.
Sure. Okay, so can you see my screen?
Yes.
Let me put it in presentation mode here. Okay, readable?
Yeah, we're seeing your next slides, but that'll work.
Well, people will get familiar with what we're going to talk about. So that's me. That's a picture of me in front of my house. And for some of you who are my age or a little older, you'll notice a gold medallion. It's a medallion home for an all-electric home, and this is a home we retrofit. And this is me personally. I'm not speaking for NIA. I'm doing this in my own volition. But we have no gas in our house. Everything is heat pump, induction, and or HRV, and so it's very energy efficient home. So what we're going to talk about today is multifamily commercial heat pump water heaters, and what does this area look like? There's a lot of people that live in these homes, and I want to talk a little bit about what size buildings they are, what are the occupants like, what are the challenges for multifamily, and what are some of the solutions. And then I want to talk a little bit about a bookcase analogy of how we're moving new products into the market, and it's kind of like the IKEA model. And then we'll give you a little bit of a preview of the first extensively studied commercial heat pump in the Seattle area that is all CO2 based for a 100-unit apartment complex. So as Amruta talked about, water heating is a big load, and in commercial water heating, it's actually bigger than 18%. 18% is the one for residential, but because of the circulation losses found in commercial buildings, it's actually somewhere between 25 and 35%. And a lot of that is a circulation loop running out there. The biggest one, of course, is HVAC. And if you can use heat pumps, remember, we're not creating energy or heat, we're transferring it. That's the idea of a heat pump. So here's how a heat pump works. And I'll just warm air comes in, crosses across the absorber and then into an evaporator coil. It then gets compressed, and that gets pushed down into the coils itself, and then you have hot water. So that's the short version. Happy to spend more time with you, but as Brian said, it's just like a refrigerator. We have more heat pumps in our structures than people know. There are refrigerators, freezers, air conditioners, dehumidifiers. I could go on. There are lots of products. We've been using them for years, and a lot of this technology, as in with a heat pump water heater, the GE model actually came out of their refrigeration division. So building types, we got low rise, mid rise, and high rise. And within this, there are unitary applications, which is a single tank, 1-to-1, or it could be a single tank with an outside unit, or it could be multiple units, or it could be multiple tanks. And we're going to talk a little bit about that. It gets a little more complicated with the different building types. But what's interesting, the upper left-hand picture there, that's what we call a low-rise, or often famously referred to as a woody walk-up. There are no elevators in them. There are outside stairwells and that kind of thing. Very common, and I've got a couple of floor plans to show where those units are. The other one, the lower left, is often found with new infill lots. They sometimes have retail on the bottom and residential above. And then the high-rise, you see a lot more of these in urban settings and in places like New York or Chicago or other places. Retail or office space on the bottom, residential above. So here's a graphic showing where heat pump or where water heaters are located within the multifamily world. And you can see the blue bar, which is the low rise. There's a vast majority of them are in unit and generally electric resistance. Then you can see that the central or the mid rises are a little bit more in the way of some gas, and then high rises you sometimes see a little more gas. But there's not that much gas into some of these things. So I wanted to just share with you the numbers of units. This is in the Pacific Northwest. And then when you look at this, this is the amount of daily hot water use in gallons. These numbers are a little staggering, but remember this is the Oregon, Washington, Idaho, and Montana territory, a significant amount. But a lot of that is electric fired. And as Amruta pointed out, in the Northwest, we're about 50-50 split with gas versus electric. But in the multifamily world, a lot of those are electric units. This information comes to us through the residential building stock assessment that NEA provides. And we've also integrated that with some data we found out from ASHRAE, and we're working quite closely with them. So who lives in these buildings? Well, here's the ratio. There's a lot of homeowners and or residents in residencies, but there are also a lot of renters. So it's equally split in households and residents. It's about 36% of all people live in a renter world for multifamily. And here's how the numbers of households break out for an apartment complex on the left, a lot of 1 member or 2 member, and then when you get into general households, it starts getting more evened out. But you can see predominantly there's a lot of single users. So I want you all to think about that, because if you're saying, well, it never worked with my family, it's like in multifamily, there aren't a lot of families living in these units. And here's another example of how they get distributed and in other locations. So it's just more information of where these tanks are and who owns them. And here is the living arrangements. What's curious to me is there are more single females living in apartment households than even single males. And then you get into single parents as a smaller percentage, and then other members. So it's a curious thing that it's, and we've seen an age split here, that it's generally people up to about age 30, 35 are living in a lot of these, or on the older side, over 50. So it's an interesting bell curve that's going on there. So here's one of the curious things that happens. New York State happens to have the highest concentration of multifamily, with 24% of all the building stock is in multifamily. In the Northwest, it's around 14 to 16, same thing with California. So this is how these things get laid out. I did a search on where are these located when you look at multifamily advertisements of floor plan layouts. And these are just these are different parts of the country, but they're generally inside the units. So they're in a water closet, or in a utility closet, or in a hallway. So to some people's questions in the text box, it's like, what about the noise, or what about the cold air within the unit? Absolutely right. These are things we need to be considering, and these are some of the solutions that we need to talk about. We'll get to that. What's funny is there are also some that live outside. especially in California or in the Southeast. You'll find them in conditioned or semi-conditioned spaces on a back porch or in a hallway or on a patio or something like that. So these are just two other examples. They're located out there. Heat pump water heaters will work any place that you can put an electric resistance. If it gets so cold in a closet or an outside closet that you have freezing pipes, you wouldn't put a water heater there anyhow. So if it gets down to any freezing potential, don't put it out there. But if it's been in there or it goes into a space that would never freeze, these heat pumps will operate down to 37 degrees by the best-in-class product, down to 43 in others. And or if it gets too cold in there, it will flip over onto electric resistance for a period of time until it gets through that hump. So here's the unitary tank solution. The picture there is sort of stripped down. The one on the right has got it fully skinned. You can see the compressor and fans on the top and the tank on the bottom. All conventional 240 units have electric resistance in the bottom of the tank, and they can handle any kind of load. They have a better first hour rating actually than electric resistance only because they've got two different engines. And one of the beauty of the 240 system is if there is a failure with your heat pump, it will flip over onto your electric resistance. That's how they've done their logic. So, they all have a 10-year warranty, which is far better than any electric resistance or gas tank, which is generally anywhere from 4 to 6 years, depending upon what kind of product it is and or where you're installing it or who's selling it. So as I've said, the challenges are they're slightly taller. They're sometimes 12 to 18 inches taller. There's a bit of noise because the electric water heater was the ideal appliance. Remember, this thing was silent. It didn't make any noise. It just sat in your closet and just a slight hum you would never hear. But it was at a price, and it's a price of 3 to 4 times the energy cost, and you absolutely have to. Then there is cold dry air that gets exhausted out of these things, but that's not a problem. We can deal with that. And then there is condensate that comes out of that. In warm summer months, you will generate, 1 to 2, maybe even 3 quarts, depending upon what part of the country you're in, of water, of condensate. Now, this is not the condensate that comes off your gas-fired furnace, which has sulfuric acid. This is just water. You can put it right onto plants. You could even drink it if you wanted to. Wouldn't recommend it just because of some of the biological things that grow over time if you don't cycle enough water through a domestic potable water system. So some of the solutions that come about for confined spaces are good venting, and we talked a little bit about noise abatement, and that can be done with additional vibration pads, dampening cloth inside a closet, and or locating it in another location. You can also proper size these things so that they can float through when anytime anybody's in there and program it so that it only runs when the occupant is out of the space. And then changing locations. We've done extensive research on this, and most plumbers have given us the feedback, and we surveyed well over 100 of them, that it would take no more than 4.5 to 5.5 hours to relocate a water heater to a new location. So if you've got it in a place that's like, I don't want it here, you can actually move it. Repiping plumbing is kind of what plumbers do, and they're known for that. The proper location is important. So here's a confined space, an example of a closet of venting in and out. It needs to communicate with about 750 to 800 cubic feet of space. This happens to be my water heater in my basement. And if I close this door, it's right at 600 square feet. So I open the door during run times. I also have a heat pump dryer in there and an inverter. So it's harvesting the heat out of these other appliances. So that's another synergistic activity. If you're using a heat pump to heat your house, it is not a detriment to that system that you have a heat pump water heater in that envelope. You're just moving heat around from place to place. One of the other things you can do, though, is you could put a split system in where you have the tank on the interior of the building, and then you run either refrigerant lines, or in this particular model, you run water lines outside the shell and you hang this. This happens to be a CO2 unit. There are several other brands coming to the market that are CO2 and or other refrigerants, but people might ask, well, so now we're putting water on the outside of the building. Isn't that a risk? Absolutely. However, they do have logic that if there is no power and or there is no heat tape engaged, it will automatically drain back and protect the system from freezing. So this is a great solution. The picture there on the left, or it's your center of it, is what it would look like in an apartment complex going out, going into different units inside the space. Perfectly great solution. So now I want to talk about central systems. Remember, this is a small percentage of the market, but it's an important one. This looks like a behemoth system. This happens to be a building in Seattle, and that's well over, I think it's close to 2,500 gallons of storage, 2 different heat pump engines, mixing valves, pretty complicated. But let me demystify it a little bit. It's just like a unitary one, where there is a condensing or an area where it gathers the heat. This happens to be in the basement of this particular building, so it harvests the heat from a garage or the thermal tendencies of the earth, and then it converts that and compresses it and pushes that into the storage tank down below, and then it's all controlled and maintained with either what they call a swing tank or an electric resistance tank that would maintain the circulation of water to all the units. So it's a pretty basic system, it just happens to be bigger. So that happens to be the compressor right back in there. Anyhow, I could spend hours talking about all the nuances of this, but we're now looking at a system approach rather than just buying all the individual components and putting them all together. And that's what leads into this next slide. What we've done in the past, think of this as the bookcase analogy. You needed a set of bookcases. You used to go down to the lumber yard, buy some lumber, get some nails, some paint, get out your tools. You'd get a craftsman to come help put it together. And that's what we have here. That's that system. It's great in the sense that it keeps a lot of people employed, but you don't have any guarantee that it's going to maintain performance. People don't know how to do it. They learn. There are mistakes. So what we're moving to now is what we refer to as the IKEA bookshelf method. All the parts will come in a box. There'll be good instructions. You can only use their screws and their tools, and it can be put together, and you will have a much more uniform solution. Ultimately, we're going to be heading to this, which is it comes in on a skid or in a container, and it just plugs in. And that leads me to my next slide, which, well, here's all the different elements. There are different water, heat pump water heaters, and then storage and everything else. So the case study that I wanted to share with you is Bayview. This is a Seattle Housing Authority project. It just went online, and it replaced a gas boiler for the city of Seattle. It was sized using open source software that's called the EcoSizer. That's available on the Ecotope website. It's funded by utilities. This is a central system that supplies, I actually got this wrong. I found out today that it's not 67 units, it's 100 units. This is all assembled in South Dakota. And I'll show you a couple pictures of that. Shipped and delivered to Seattle on a truck, and it uses a CO2 system made by Mitsubishi from Japan. And then it was installed in less than 2 days, and there was an outage of less than 2 hours for all 100 units. It's fully functioning, and we're actually getting load shifting capability out of it. So here it is built in, this is a picture of it being built at the factory in South Dakota. This happens to be a company called Stephas. They used to make a lot of gas and oil equipment and pumping systems for the gas and oil industry. They're seeing the light that that industry may be going away, and so they're going to start building these in their factories. It arrives in Seattle on a truck, a little lowboy, and then it gets put onto with a crane and swung into the building, and then they're good to go. So lots covered there, but I just wanted to let you know that the commercial and central and multifamily market is getting addressed with heat pumps. It's no longer leading edge. It's becoming sort of the norm, and that's the goal for many cities across the U.S. California is working with 52 cities to not have any gas central systems go in. City of Seattle is working that way. Other cities across the U.S. are doing the same thing. So back to you, Brian.
Thanks. We're hoping Portland will be there soon. I know you can't comment on that, but we're working for it. Well, great. So we are a little bit over time. If Geoff and Amruta can stay on for just a couple more minutes, we've got a ton of questions. Brian, I was thinking we could do a rapid fire question, since we have said this has piqued the curiosity of so many of our viewers. If that works for folks, we can see how many we can get in the next 5 to 7 minutes.
Okay, let's do it. Go.
All right. So somebody was asking, what is the ROI on some of the initial higher upfront costs? How much will you pay? How quickly will you pay that back?
I can cover the residential ones. So in the Pacific Northwest, it's about 3 to 4 years. Geoff, do you want to, since it is like a quick answer, Geoff, do you want to go for the commercial ones?
Sure, we're seeing a payback of less than that, especially depending upon what you want to talk about with the future value of that building. So the return on investment might be 3 to 4 years in a commercial setting, but even less with unitary ones going in a commercial building.
What do you guys see happening in terms of refrigerants? You know, I mean, we saw that there were some different ones available right now, but in terms of regulations, anything interesting happening there?
Yeah, so California, the CARB, California Air Resource Board, they are coming out with regulations which are in fact going to require not just water heating, but also the space heating related, like heat pumps, to have low or medium global warming potential refrigerants. Like I have heard the timeline is somewhere close to 2023, 2025. So in few years, you will start seeing even that market, like the space heating market, to be adopting low global warming refrigerants as well.
I would chime in there that refrigerants is something we should all be concerned about, but it's not a reason not to embrace these devices right now. They're way better than natural gas from an environmental impact with the refrigerants we have today. But the refrigerants, you know, it's always great to make them better. But I don't let that scare you on these devices. There's nothing to be afraid of there.
Well, there was a study that was recently done about this, and I think by NRDC, and they said, even if you run your heat pump water heater for the 10-year warranty period and then vent it all to atmosphere, you're still coming out far better ahead than running a natural gas water heater.
Right.
And just a reminder, these are all closed loop systems. So the refrigerant is like within it. So it should not matter what the refrigerant is. So just adopting heat pump water heaters is key, and we should let the manufacturers and the regulations take care of the refrigerants.
Perfect. That's great. Somebody had a quick question about recirculating pumps. This came up in our webinar yesterday as well. Can they work okay with heat pump water heaters?
Well, they can, and they can also be the death knell of a heat pump water heater. So I run a recirc pump in my house, and there are plenty of products out there that work, and they need to be what I refer to as on-demand recirculation pumps. So they're tripped either by a motion detector or a mechanical switch. It runs a loop of a slug of hot water back and deposits it back in the bottom of the tank, and they work just fine. In my house, it takes less than 7 seconds, and I have hot water throughout the whole place. If you're building new, have a dedicated return line. If you're doing a retrofit, do it with a dedicated crossover line on the furthest fixture.
Speaking of on demand, can you either of you comment on how these heat pump water heaters compare to either gas or electric on demand systems, water heating systems?
When you talk about compare, are you talking about performance, or are you talking about cost or maintenance?
I would say from cost and a carbon standpoint, maybe.
So that's a huge can of worms conversation. And I would say, by and large, the general answer is these perform far better for a carbon footprint over the life of the product. Remember, these have a 10-year warranty on them. Most tankless water heaters don't, and there's an annual maintenance. And then the stop-start of every tankless is another potential bit of unburnt fuel that is going into the atmosphere or into your space. And that's a lot of NOx, SOx, and formaldehyde. People may not know that there is formaldehyde in what was referred to as natural gas.
Yeah.
Yeah, and I think one of the slides does compare all the different water heating technologies to with heat pump water heaters, and particularly shows the carbon emissions and operating cost impacts. So I guess that's like my second last or second slide, if you want to.
We'll be sending these slides out to people, by the way. Anyone who is interested, we'll make sure that's available. We'll send it to everyone.
Right.
What do you got, Joe?
Someone was asking, how much cooler does it, for your example, your basement, Geoff, how much cooler does if it's not vented, does the heat pump water heater make the space?
So a lot of times it sort of depends on the volume. If you've got sufficient volume, it will reduce the temperature 2 to 3 degrees, depending upon, again, the draw of who's using it and how long. But it's 2 to 4 degrees. I ran mine in my previous house out in the garage, even when it got down as low as 32 degrees out there once, and it ran for probably 4 or 5 hours, and it forced it down into that 32 just because it was so cold. But it was about 20 degrees outside. But generally these things work just fine. And if you've got worries about it, you can always put it in the hybrid where it's both electric and heat pump.
Mm-hmm.
Great.
So someone asked about clearance. They're a little bit taller, like you mentioned, than other units. Would it work in a space that's only 6 feet tall?
They can, and we see them in other parts of the country in attics and in what we refer to as the crawl space from hell, where you have to lower it in and take several guys and turn it around and all kinds of weird things. As long as it's got enough room to have intake and exhaust, and you can service the air filter, absolutely. And you need probably 2 or 3 inches on the top to service most of the air filters.
For folks like my family that doesn't have a garage or basement unit, we vented ours out and have had great experiences. I mean, do either of you have any thoughts? Is it something you would recommend, ducting your heat pump water heaters, ducting the exhaust and the intake?
Yeah, I would say if you're doing any ducting, if it's in and outside the envelope, both duct in and duct out. Don't depressurize or overpressurize your envelope. If you're ducting it from one part of the house to the other, don't worry about it. And we've got plenty of studies that we've done that in very cold climates where they're ducting it out of an area that they didn't want that cold air, like in a TV room or adjacent area, and they just dump it into your utility closet or some non-used space.
We should probably wrap up, but I got one question, maybe sort of like let's dream of the future here. It's this whole idea about moving heat from one space to another is really interesting. And we have devices in our homes that we have one device that heats and another device that cools, and they use these same technologies of moving heat from one place to another. What do you guys think is possible in terms of systems that take advantage of other devices to capture waste heat from one place to use here, or waste cooling from one place to use over here? Is that in the cards? Are we going to see things like that maybe connect our refrigerators and our air conditioners and our water heaters? They're all sharing this energy exchange, so they're all more efficient. Is that a thing?
Yeah, I can try to take that one. So in the commercial world, that is a thing. And for years, I have seen like mechanical designers trying to capture like the waste heat through heat recovery, whether it is heat recovery chillers or so yes, it does. It is a big thing. And but in the residential, through these hybrid systems, we see that happening, like especially with heat pump water heaters. Like the recommendation is, in fact, if you can, then install them close to like a laundry room or an IT closet where there is waste heat, and your heat pump water heaters are in fact recovering that heat. So like we will see this more and more with this whole industry getting to efficient products. Geoff, do you want to add anything?
Yeah, we're actually testing a unit that does both domestic hot water heating as well as space heating, and the extension into other applications like a refrigerator or a freezer or a dryer. It's not hard to imagine. In fact, Oak Ridge National Labs is working on some products now that will have circulation, refrigeration circulation loops within houses, much like you would a hydronic system, for just that neat.
One big heat pump that powers all your appliances.
One heat pump to rule them all.
Well, what's funny is it won't be that big of a heat pump. It will be the biggest load size, and maybe a little bigger, but not much. So it'll be a 2.5 ton system for a standard 3 or 4 bedroom house.
Wow.
That's awesome. The future is going to be great. All right, we should probably wrap up here, Joe.
Yeah, sounds good. I put a link to our webinar tomorrow on grid interactive buildings. Join us if you come to all 5 webinars in Electrify Week. You get a personal high five, or maybe an air 5 COVID safe from Joe and Brian. So, so try to join us for every day at noon for the rest of the week.
And as always, if any of you have questions about electrifying your homes, or if you're on that journey towards getting rid of natural gas in your home and you have some questions, feel free to send them our way. If we can't answer them ourselves, we know so many people like Amruta and Geoff now who can help us answer pretty much every stumper you have. So send them our way. We'd love to help you. And check out our website where there's more tips and information and even some discounts on products and things to help you on your way. And good luck, everyone, with your electrification projects, and hope to see you at one of our upcoming webinars in the future. And thank you, Amruta and Geoff. It's been fantastic to have you today.
Thank you all.
Absolutely.
So.
Take care.